Hello everyone. Welcome to another lecture of the course Digital Signal Processing. In the previous lecture, we had introduced the concept of circular convolution and derived its expression, which is given as x1 of n circularly convolved with x2 of n is equal to summation m running from 0 to n minus 1 x1 of m into x2 of n minus m mod capital N. So now let us look at a simple example, and for that let us consider x1 of n equal to 1, 2, 3, 4, where this 1 is located at n equal to 0, and let us consider this x2 of n as 1, 1, 1, where this 1 is located at n equal to 0. So now if we observe, the length of the first signal, that is L1, is 4, and second, the length of the second signal L2 is equal to 3. Now we need to find the circular convolution, and for that we require the value of n. So the first step, that is step 1, is check for given value of n. If the value of n is not given, then consider the value of n as, or the value of n greater than or equal to max of the lengths of the signal. So the value of this n should be considered at least equal to the maximum value of the length of the signals. So this has to be done when the value of n is not given to us. So in our considered example, we need to find the value of n, and if we look at the lengths, then the value of max of L1, L2 is equal to 4. So let us consider the value of n as equal to 4. We can consider the value of n as 5, 6 and so on, but let us consider the minimum possible case. So let the value of n be equal to 4, and then once we have the value of n, we need to make both the signals equal to the length 4. So we know that this x1 of n is equal to 1, 2, 3, 4 of and has a length L1 equal to 4, but this x2 is length 3 signal, so we just need to append zeros in order to get the length 4 signal. So this x2 of n has to be made length 4, so it is given as 1, 1, 1 and a 0 appended at the end, and this one is located at 0, that is n equal to 0. Once we do this, the next step is to represent these signals in a circular fashion. So the step 2 is represent x1 of n and x2 of n in circular fashion. So let us consider x1 of n first. So this is for x1 of n. So now we know that x1 of 0, so this x1 of n is given as 1, 2, 3, 4, and we know that this x1 of 0 is equal to 1. Then we have this x1 of 1 is equal to 2. Then x1 of 2 is equal to 3, and this x1 of 3 is equal to 4. So we have considered this as the increasing direction of n, and this is the circular representation for x1 of n. Now if we consider x2 of n, then it is given as 1 1 1 0. So again we will start from this point. So we have 1 here, then we have 1, then again we have 1, and then we have 0 here. So this is x2 of n, and this is the increasing direction of n. Now we need to keep in mind that the location of n equal to 0 should be taken same for both the cases, as well as we need to keep the direction of increasing value of n same in both the cases. Now once we have done this, the next step is to flip the signal x2 of n, and this flipping will be again a circular flipping. So if we observe this expression here, we have x1 of m and x2 of n minus m. So basically this minus m is simply flipping of the signal, that is x2 of n. So we have this representation of x1 of m, that is 1 2 3 4, and this x2 of m, that is 1 1 1 0. Now we need to keep this x1 of m as it is, that is 1 2 3 and 4, but we need to flip this m, this x2 of m. So we would be having this x2 of 0 here, that is 1, then x2 of 1 would be located at x2 of minus 1, so it would be here. Then we would be having x2 of 2 located at x2 of minus 2, so it would be here, and this 0 would be located here. So we have just flipped the locations of this 1 1 1 0 as 1 1 1 0. So this is simply a circular flipping, but the increasing value of m still remains the same. So this is the step 3. That is flip x2 of m. And once we have done this, we would be shifting circularly this x2 of n in this direction by 1 unit till 1 unit n times, and multiply the corresponding elements and add them. So let us consider the values of n from 0 to n minus 1. So for n equal to 0, we have the position of x of 1 of m as it is, that is 1 2 3 4, and this is x2 of 0 minus m, that is we simply have x2 of minus m. So we had seen that it is given as 1 1 1 0, and now what we need to do is we need to just multiply these corresponding elements. Because if we look at the initial expression, so after shifting, we need to multiply these two signals and add, and this we need to do for n minus 1 time, that is from 0 to n minus 1. That is the value, that is this shifting is to be done from 0, addition is to be done from 0 to n minus 1 times, and the value of this n, would be also ranging from 0 to n minus 1. That is, this n is also to be varied from 0 to n minus 1, that is 0 to 3 in our case. So when we multiply the value of x of n, that is after multiplication, and for n equal to 0, it would be given as 1 into 1 plus 2 into 0 plus 3 into 1 plus 4 into 1, which is equal to 8. Now if we shift this signal, that is x2 of minus m, by 1 unit, that is we need to rotate this outer circle in the clockwise direction, that is in the increasing direction of n. So this one that was here would be located here, this one would be located here, the one which is here would be going here, and this 0 would be located here. So we have this situation something like this. So it is the one which was present here is now available here, the one which was here is now available here, the 0 which was initially here, that is here, is now located here, and the one which was located here is now available at this position, that is here. Now again we need to multiply the corresponding elements. Like this, and add them. So we have the value of x1 is equal to 1 into 1 plus 2 into 1 plus 3 into 0 plus 4 into 1, and this comes out to be 7. Now if we need to have the value of this n as 2, which means that this x2 of minus m is to be shifted by 2 units. That is, this one which was located here should go here, this 0 should be going at this location, and so on. Or in other words, we need to circularly shift this outer circle of x2 of 1 minus m again by 1 unit. That is, the one which was located here would be going here. So if we observe it in this diagram, the 1 or the 0 which was located here would be now available at this location. Similarly, the 1 which was initially here when we had a shift of 1 would be now available here. The one which was here at this location would now be available here, and so on. Now again we would be multiplying it with the corresponding elements of x1 of m. Therefore, what we have is the value of x of 2 is equal to 1 into 1 plus 2 into 1 plus 3 into 1 plus 4 into 0, which is equal to 6. Now similarly, if we need to find the value of x of 3, now again we would need to shift this outer circle by 1 unit, that is, this 0 would now be available here, this 1 would be here, and so on. So what we obtain is something like this. So this 0 is which was initially here is now available here, and similarly we have shifted the outer circle in the clockwise direction. Now again we need to combine these elements, or we need to multiply these corresponding elements of x1 of n and x2 of 3 minus m. So it is x1 of m multiplied by x2 of 3 minus m, and we need to add it. So we have x of 3 is equal to 1 into 0 plus 2 into 1 plus 3 into 1 plus 4 into 1, and this is equal to 9. Now if we go ahead and try finding the value of this n, try finding the value of x of 4, so again we would be needing it to be shifted by 1 unit, and we would be having it as 1 0 1 1. And if we go back and check this original shifted version, that is this x2 of minus m, that is here, we would again get back to this point, which means that we would be having x of 0 would be equal to x of 4, which means that again going ahead and shifting it further in the circular fashion would be giving us the periodic numbers, or would be giving us the repetitive sequence. So we will be completing our operation when we have reached the shifts till n minus 1, that is 3. So we would be shifting the sequence that is ranging the value of n only from 0 to 3. And now if we observe the convolution that we have obtained, or the circular convolution that we have obtained, has resulted into a sequence of 8, 7, 6 and 9. So we have x of n which is given as x1 of n circularly convolved with x2 of n as a sequence which is equal to 8, 7, 6, 9, and this 8 is located at n equal to 0. So in this lecture we have considered an example for circular convolution which is given as x1 of n as 1, 2, 3, 4 and x2 of n as 1, 1, 1, and the first step is to check the value of n, and if it is not given, then consider the value of n as at least equal to the maximum of L1 and L2, where this L1 and L2 are the lengths of the given sequences x1 of n and x2 of n. And once we check the value of n, we need to make both of these signals equal to the length n, and if the value of n is higher than the length of the signal, we need to append zeros in order to make it of length n. Once we do that, the next step is to represent x1 of n and x2 of n in a circular fashion, that is something like this. And things that we need to keep in mind is we need to have the initial location of zeros at same locations for both the signals. Moreover, the direction of increasing n should be also kept same in both the cases. The next step, that is step 3, is to flip this value, this signal x2 of m in a circular fashion, that is find this x2 of m, which can be done by simply flipping this in a circular fashion, that is the one which was located at 1 should be now located at -1, that is in this fashion. So this leads us to have the value of x2 of -m, and once we have flipped, then we need to shift it. So the step 4 is shifting n from 0 to n minus 1, then multiply the corresponding elements and add. So when we have the value of n as equal to 0, so it is simply equal to x2 of -m, and then we multiply the corresponding elements and add them, and this gives us the value of x of 0. And now when we need to find the value of x of 1, that is when the value of n or the value of shift is equal to 1, we need to rotate or circularly shift this outer circle in the increasing direction of n, that is the one which was present here will now be here and 0 would be now here. Similarly, this 1 would be shifted at this location and this 1 here would be shifted at this location. So what we get is something like this, and again we need to repeat the same thing, that is multiplication and addition, and this has to be repeated for n equal to 3. So for n equal to 0 to n minus 1, that is 0 to 3, we need to repeat the same things. And then what we are left with is a sequence that is x1 of n circularly convolved with x2 of n, which is given like this. That is, for our case it comes out to be 8, 7, 6, 9, where this 8 is located at n equal to 0. So let's stop here. Thank you.